Hey everybody, this is Larry. This is day 9 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Day 8, sorry. Let me know what you think about today's problem. Oh, okay. I thought I'd do a weekly premium thing. I'll probably do the weekly premium thing tomorrow. Today, as you may guess, running a little bit late. Everything is a mess today. But yeah, let's take a look at today's problem. We have 1829, maximum XOR for each query. Okay, so you have a sorted array of n non-negative numbers and an integer maximum bit. You want to find a non-negative integer such k is less than 2 to the max bit such that is maximized. K is the answer to the ith query. We move the last element from the current array now. So you have this. Right. So you started out with all the numbers. Oh, XOR K. It's maximized. Okay, I misread this actually, so this isn't so bad. I don't know if it's so bad yet, but I just was not able to read it correctly. I saw that this was an array, and I was trying to figure out what k is, but it's XOR k, right? So what is the maximize of all this thing, or this function, right? I think that's the idea to kind of think about, right? Well, the maximum thing that this can be is that this is going to be all ones in binary, of course. And we know that it's going to be 2 to the max bits. So that means that, well, that means that we have this thing, and the only thing that we, I think I misread this one again, actually, hang on. Oh, no, yeah, sorry. Yeah. No, I think I read it right, but it's such a weird phrasing. But basically, this is maximized when all this is equal to 1. And because we get to choose k, we can always make this equal to 1. And here, all we have to do then, right, is that, well, we know what this is what I'm going to say, because we're trying to find k. We know what this is because, well, that is literally, you know, the array, right, the input array. So then now we just have to figure out, you know, how to solve for k. And of course, the way to solve for k, there are a couple of ways you can think about it, but you could XOR what, you know, this is this, all these ones on both sides. So if you do something like that, you would have this XOR all the ones. I didn't even count. So and then on the right side we 0. And then now the second thing you do is XOR k. So then, well, you XOR k on both sides, right? And to get rid of it, and then k is equal to all this stuff. And that's really the idea behind the first query. And then the second query is just the same thing, really. And you could even do it in either direction if you like. I think the way that they phrase is a little bit confusing, because then now you just only look at one number, and then the second number, or the first number plus the second number, so forth. You can also do it backwards, because XOR has like some fun properties like that. If you don't know what I mean, play around with XOR. I think a lot of these problems you have to play around with them. I think a common thing that people think is that, like, oh, Larry memorized all these tricks and observations and all these things about XOR. And maybe and what I mean by that is that I don't go out to look at a list of XOR facts and try to memorize them. And the truth is that I've done probably hundreds or maybe even thousands of XOR problems at this point, and you just kind of notice things as you go along, right? So yeah. So that, and I mean, of course, I could explain the proofs and these things, and that's fine to kind of, as a communication thing. But the only way you really learn is just to kind of keep going and playing with them, so that yeah, and when you remember them, well, you will know, right? So anyway, so yeah, so then now we can do something like for x in nums, right? So okay, so maximum bit, so we're gonna have so 2 to the maximum bit is just gonna be I usually write shift stuff because that's for bitwise stuff, it feels more natural, but in the interest of maybe slightly more clear, then I have this, right? And yeah, and this is maximized when there's or negative or 1, so it's just this minus 1, right? So let's just call it m for max, maybe, or just call it max. And then now yeah, and then we have defined k. Yeah, we have defined k, so then now we can do current equals 0, we current x, right? And then now we have an answer thing that we return. Of course, the way I'm doing it is backwards, so you have to keep that in mind. So we append current XOR max, and that's it. We reverse it at the end to get the right answer, or in the right order anyway. And yeah, looks okay, looks Gucci. And that's pretty much it. Why was my thing taking so long last time? Did I do something funky? No, it seems like I did the same thing. I don't know why it took like a whole 1 second. But either way, for loop really. For loop and XOR. But yeah, yeah. I mean, I think this problem is a little bit tricky in that reading this is kind of like, I don't know, maybe I'm just not awake enough or whatever, but yeah, this is going to be, let's just say linear time-ish, and linear space. So yeah, and there's some stuff that you could say maybe is a function of max or number of bits or something like this, but keeping in mind that this is only going to be as big as the size of the input in the number of bits, I guess, in theory. How if you want to be more precise, you probably can. For me today, maybe I'm just a little bit tired. But yeah, linear time, linear space, keeping in mind that both of that is the size of the input, so, and linear space is the size of the output, so you can't really do better, is the lower bound. And that's what I have for today. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later. Take care. Bye bye.